Hello everyone, in this video we are going to discuss about the debugging in Terraform. Overview of debugging Terraform. Let's firstly discuss what is the exact meaning of debugging. Debugging is the process of finding the root cause of a specific issue. Let's take example, we do have any challenges while running Terraform plan and we are not able to understand what is the exact error. In that case, we need to debug the issue. To debug the issue, what is the prerequisite? The prerequisite is to have all the logs. Okay. So in Terraform has detailed logs which can be enabled by setting the tf underscore log environment variable to any value. You can set tf underscore log to one of the log You can set tf underscore log to one of the log levels. It is trace, debug, info, warning, or error to change the verbosity of the log. So what does it exactly means? As we do have discussed, if we need to debug any issue in Terraform, we need what? Logs. By default, the logs are not generated. To generate the logs, what we have to do, we have to set up an environment variable called as tf underscore log. Okay, and we do have n number of options which are trace, debug, info, warning, and error. By default, if we are going to set up the tf underscore log value as trace, so automatically it will consist the detail about the debug, information, warning, and error. If you are going to set up the tf underscore log for debug, it will have all the values for information, warning, and error. And same thing will happen for information and warning. So whenever we run our Terraform init, this is the default. So whenever we run Terraform init, so this is the default value which we are getting. But if we want to generate the logs also, so as discussed, what we have to do, we have to set the environment variable, and it is tf underscore log. And what are the value we are mentioning? We are mentioning the value trace. So it will have the information. So trace will consist debug, info, warning, and error. So after setting the environment variable with trace, when we are going to run the Terraform init, it will have info, debug, I would say trace. So so after setting the tf underscore log value as so So after setting the tf underscore log value with trace and we are going to run Terraform init, it will have detailed information. As we do have discussed, when we are going to run Terraform init from our local machine, it is going to connect with our API and then it will fetch the details. And what we are going to have, we are going to have .terraform folder, which will what we will have? We will have Terraform folder. What we will have, we have .terraform folder which will have all the details for the provider, and then we are going to have .terraform log.scl which will have the version value. So if you go through all the logs, you will see the detailed explanation about each and every step, and these logs can be used for debugging any kind of issue. But in real time scenario, what we do not want all the log present while running our Terraform init. Instead, we want all the logs to be saved in a dedicated file. So in that case, what we have to do, we have to run a command called setx for setting the environment variable, tf underscore log underscore path, and where we want to save the logs. So in that case, all the logs will be saved inside this file, and our Terraform init will be and our Terraform init will not have the logs. Okay. So thanks a lot for watching the video. In the next video, we are going to do a quick demo on the debugging in Terraform. Hi everyone, in this video, I'm going to do a quick demo on debugging in Terraform. So the first step which I'm going to do, I will copy the path, will open the CMD, I will run Terraform init. If you see here, while running the Terraform init, we are not getting any logs. Let me run Terraform plan also. If you see here, we are not getting any logs in Terraform plan. What we have to do next, as discussed, we have to set up the environment variable. The command is setx, then tf underscore log, and we do have n number of option, which is trace, debug, info, warning, and error. As discussed in the last video, if you're going to enable trace, then it will have all the values. And same for debug. If you're going to mention debug, it will have information, warning, and error. So I will mention here trace. Okay. So environment variable has been set up. If I'm going to run again Terraform init, we are getting the same value. What we have to do, we have to open one more CMD and then change the path for our Terraform configuration. And then let me run Terraform init. See, we are able to see all the logs in terms of when we initiate it, what it will do from our local machine. It is going to connect with Azure RM provider, and then it will create .terraform folder, which have all the details regarding the provider, and then terraform.log.scl, which have the version detail. If you go through this log, you'll get the proper explanation about each and every step. Let me run Terraform plan also to see the log status. And finally, the output is no changes. Your infrastructure matches the configuration which we have initially seen while running the Terraform plan. Okay, but in real time scenario, we do not want these logs to be present inside our CMD. So in that case, what we have to do, we have to set up the environment variable to save all the logs inside the file. To do this configuration, what is the command? The command is setx tf underscore log underscore path, then our folder path. C colon, I would say, log test log dot log. Here, the environment variable has been saved. If I'm going to run again the Terraform init, still we are having logs in our terminal. If you see here, we are not having any logs in our CMD. In, in this case, all the logs are getting saved in our C drive under test log. And inside our C drive, if you see, we are having test log file. Let me quickly open it. It will have all the logs for our Terraform init plan and apply. Hi everyone, in this video I'm going to discuss about the Terraform modules. Example of Terraform module. Example 1. Your manager has asked you to create resources for a project. You are required to set up the following services. It is app service plan, function app, storage account, key vault, event hub. In example 2, your manager has asked you to create resources like AKS, Azure Container Service, API, and key vault. Till now, what we have discussed, if we create any resource, what we have to write? We have to create a file, I would say main.tf, and in this main.tf, we have to write our resource block configuration for each of the resources. The second thing which we are going to do, we are going to create a variable.tf, and in this variable.tf, we are going to declare all the variables. The third thing, it would be output block. The output block, it would be responsible to output the values. The third one which we are going to mention, it would be our provider block, where we are going to mention the provider configuration. The same thing we are going to do here also. We are going to write main.tf, and here the resource block, it would be for AKS, ACR, API and the key vault. And the values, we are not going to do any kind of hard coding in the resource block. So we need to create a variable, then output. We are going to create output.tf to output the values, and finally we are having providers.tf. This is what we have discussed till now. So, overview of Terraform module. Terraform modules allow us to centralize the resource configuration and make it easier for multiple projects to reuse the Terraform code. Instead of writing code from scratch, we can use multiple ready-made modules available. The DRY principle in Terraform, like in general software development, stand for do not repeat yourself. This principle encourages writing infrastructure code in a way that avoids duplication, promote reuse, and ensure maintainability. So what does it exactly mean? In the last example, we do have example A and example B. In both the example, what we have done from scratch, we have started writing our resource block, then our variable, then our output block, then our providers. The same thing we have done in the project B also. Resource block, then we have created variable.tf, then output, and then providers. So in real time scenario, we are not going to write our code from scratch. Instead of it, we are going to follow module approach. So what is the exact meaning of module approach? It means we can, instead of writing code from scratch, we can use multiple ready-made modules available. So we're going to have dedicated repo for modules, which means we are going to write here resource block, variable, our output and provider. Okay. And we are going to call this value from the project A, project B, project C. And in this module, I would say we are going to have all the configuration. I would say app service plan, function app, storage account, key vault, then our AKS, ACR, APIM1. So for all these resources, we are going to write a module for it. And then we are going to store in this dedicated repo. And according to the requirement, we are going to call it in project A, project B, project C. Maybe in project A, we only need Azure function app, app service plan, and a storage account. Maybe in project B, we only need, I would say, key vault, storage account, and AKS. And in project C, what we are going to have, we are going to have, I would say, AKS, ACR, and APIM1. So we do not need to write any code from scratch. We only need to call the value, and this is called dry principle, which means do not repeat yourself. We have to write our code and store in dedicated repo, and we are good to call this modules according to our requirement. So what is the exact best practices for creating a module? Define a clear module structure. A well-structured Terraform module should to navigate. The basic structure of Terraform module includes, we are going to have main.tf, then variables.tf, outputs.tf, readme.tf, providers.tf, and version.tf. The main.tf, I would say if I'm working on ACR module, what I'm going to do, I'm going to write the resource block for ACR. Then I'm not going to hard code any value. I'm going to create a variable for it, and all the variable will be declared in variables.tf. And I'm going to write output.tf to output the values which has been created. Readme.md to make it more user friendly. Providers.tf, where we are good to mention the provider configurations, and the same for versions also. So after creating the module, a dedicated test directory is set up to validate the module functionality with configurations and test cases to ensure the module behave as expected in different scenario. So what does it mean? Here what I have done, I have created one module for virtual machine, and in this virtual machine module I have created dedicated file public IP.tf, then our providers.tf, variables.tf, virtual machine.tf, and vnet.tf. Okay. I have not hard coded any value to test the configuration. Is it up to the mark or not? I have created dedicated folder name called test inside a folder name called VM, and here I'm having main.tf. So locally, I'm running my Terraform configuration to check is it up to the mark or not. Calling a module. Module source code can be present in wide variety of location including. What does it mean? In the last slide, we discussed dedicated repo for a module. So this dedicated repo for a module can be in GitHub, in local path, Terraform registry, Azure repos, HTTP URLs. To reference a module, you need to make use of module block and source. So it means we do have dedicated repo. We have to call it for project A. To reference a module, you need to make use of module block and source. So it means we do have dedicated repo and we want to call it for project A. So what we have to do, we have to create one file, I would say test.tf or whatever the name you want to mention as per your naming convention. Then we need to mention module, and then whatever the module you're calling, if you're calling ACR1, you're good to mention ACR, or APIM if you're calling, you're good to mention APM1. If you're calling virtual machine, like it depends what like which module you're calling, you're good to mention any name here. They're good to mention the source, and here it would be the path where your module has been created. If it is present in Bitbucket, you're good to mention the URL of the Bitbucket, or else wherever you have stored your module, you need to place mention the values. Terraform uses this during the module installation step of Terraform init to download the source code to a directory on local disk so that other Terraform command can use it. So what exactly means? So initially we are having our source module, I would say dedicated module where we have written our modules, and here in project A we are calling. As we do have mentioned, it is mandatory to mention module keyword, then whatever the module you are calling, you're good to mention then the source. In the source, we are good to mention where our dedicated module is present. If it is inside the local path, then you have to mention the local path address. I would say like this. My source module is present inside two folders back. While here I have stored my source module inside the bit bucket. So I'm mentioning the path of the bit bucket. So when I'm going to run Terraform init, what is going to happen? It will download the source code in my local machine. And at the runtime, what we have to do, we have to pass all the values, whatever the variables we do have created, and we are good to run Terraform plan and Terraform apply. Okay. So in this case, what we have to do, we have to only pass the required values and we are good to create the resource. We don't need to write any resource block from scratch. Okay. Root versus child modules. Root module reside in the main working directory of your Terraform configuration, and this is the entry point for your infrastructure definition. A module that has been called by another module is often referred to as a child module. So the place where we are going to store our module, it would be our root module, and the place where we are going to call all this module to pass the values, it will be our child module. Hi everyone, in this video I'm going to do a demo on Terraform module. So what we have discussed till now, if we want to create any module, the first thing it would be main.tf, which will be responsible for all the resources block. Then we are going to have provider for all our provider configuration, then variable file for all our variable configuration, and the output block. Okay. In this video, I'm going to create a module for virtual machine. So the first thing which I'm going to do, I'm going to open the official documentation of Terraform and copy the details here. I'll create a file name called as main.tf. This is the official documentation of Azure RM underscore Windows underscore virtual machine. I'll click on copy. I'll paste it here. Okay. So to create any virtual machine, what are the resources it would be required? The first one, it would be private IP, then public IP, then I would say it would be our virtual machine configurations, then our NIC card, and then the public IP which we do have created, we have to connect it to NIC. And in the virtual machine, we are going to have our OS disk configurations also. So I have copied it here. We'll create a file name called as providers.tf, and here I will copy the values for providers.tf. The first thing which we want to create is private IP. So for the private IP, the value will come from the subnet, and the subnet value will come from the VNet. So in this example, we are going to create our own virtual network. So let me but let me divide it. If you see here, we are having our virtual network example. I'll create a file name called as vnet.tf and will mention it here. Okay. Then what is the second configuration we need to mention? We need to create a public IP. To create a public IP, we need a resource name called as Azure RM public IP. Let me open a tab here. I will mention public IP Azure. I'll mention public IP Azure Terraform. Here we do have the configuration. I'm going to copy it and we'll create a dedicated file name as public IP.tf. And we do not need a resource group configuration here. So this is the public IP which we do have mentioned. Our VNet configuration has been mentioned. Then the third one, it would be our virtual machine.tf. If you see here in main.tf, we are having our virtual machine configuration and NIC. I will copy and paste it. We have already copied the provider configuration, and the final it would be our resource block. Okay. Till now, we have all the required files. Okay. For main.tf, public IP.tf, providers.tf, virtual machine.tf, and vnet.tf. As I do have mentioned, for public IP, we need to connect to the NIC card. So what would be the step? I would say come inside the virtual machine. Here we are having our virtual network. We are having our Azure RM network interface. I will mention here public IP address. What is my public IP address configuration is? It is Azure RM dot example dot I need ID here. If you come here in the official documentation, just Control F, I would say public IP address ID. So it requires reference to a public IP address to associate with this NIC. Okay. So the initial step has been completed. We have created file for each and every resources. So the next step is creation of our variables file. Variables.tf I'm going to create. In variables.tf, if you see here in Azure RM Windows Virtual Machine, the Linux virtual machine value is hard coded, the size is hard coded, admin username is hard coded, the password is hard coded, I would say OS disk, and the source image reference. So what we need to do, we need to create a variable for it. Basically, we do have two options while creating a variable. The first option, it would be create a variable for each and every value which we do have discussed till now. Apart from that, we do have the second option in which we are going to declare type as object and in a single go, we are good to declare n number of variable inside it. So let's follow the second approach. I will mention variable vm underscore configs. Here I'm going to mention type is equal to object. And what is the first thing I want? I want virtual machine name. I'll mention here as vm underscore name. Then the second one, what it would be? It would be my size. To make it more user friendly, I'll mention vm underscore size. The third value it would be admin underscore username. And the fourth one it would be admin underscore password. Here it is already connected to my NIC card. So in terms of caching, it would define and storage account type. I will mention here as storage account type. Then it would be my for OSDS configuration. I'll mention here as publisher. Then I will mention here at as offer. Then our SQ. And the next last one it would be our version. Okay. We are going to mention the data type as a string. So what we need to do to call this value, the first thing it would be var dot vmconfigs dot our virtual machine name. The same thing we are going to follow for the stand size. I would say it would be var dot vmconfigs dot admin username. Then the admin password, and here I would mention here I would mention the storage account type, and the same thing I'm going to follow for publisher, offer, SQ, and the version. Okay, so what we have done till now, we have created variables for our virtual machine configuration. If you see for Azure RM Windows virtual machine, all the values are variable apart from the NIC card. All the values are in a variable, and this some of the values we do not want to update, so we are good to ignore it. While in the case of NIC card, rather than taking an input from the user, we need to mention, I would say, function called format. Then the format it would be percentage %s, I would say NIC, comma, the value it would be var.vm configuration. So in this case, what is going to happen? The format will follow as this string hyphen nick, and the string value will come from our virtual machine name. If I'm saying it is a demo virtual machine, then automatically it will name as demo hyphen nick. So this is the basic functionality of the format function. We have created variable for each and everything which are required to input from the user. So the second one which we are going to do, it would be inside our public IP. Again, for the public IP, we are going to follow the same configuration. It would be format we are going to mention, then string value it would be hyphen public PIP, and the value it would come from our virtual machine configurations only. So again, the same thing will happen. We are going to have our virtual machine name, and at the end it will have PIP, which mention it is the public IP for this virtual machine. I do not need any tag right now, so I will remove it. And other values look good. I always need a static value, so that's why I haven't created it as a variables. If you come to the VNet part, in VNet, what we need to create variables for our virtual network name and this one. So I'm going to create a variable name as vnet underscore config, and I'm going to follow the same approach rather than creating a variable for each of the values. So it would be type is equal to ob type is equal to, I would say, object. The first thing it would be our vnet underscore name. I will mention here. Then the second thing it would be vnet underscore address space. The third one it would be subnet underscore name, and it would be subnet underscore address underscore space. Okay, so the vnet name should be string, while in the case of vnet address space it would be list of, I would say, string. And for the vnet name again it would be string, and vnet address space it would be list of string. Why I have mentioned list of string instead of string? Because if you see here, the default value which we are passing in a square bracket will define about the list of string. Apart from that, you're good to look into the official documentation also. So I will update the value as here var dot vnet config dot vnet name. The same thing I'm going to copy and paste here. At the end, it would be vnet underscore address space name. Here also I'm going to do the same thing, and it would be subnet underscore name. Sorry, subnet underscore name, and then here it would be subnet underscore address space. You see, we have updated our vm.tf configuration, the vnet.tf, then our public IP, and we are left with main.tf. In main.tf, we are good to create a variable, I would say rg underscore name, good to mention as type is equal to string, and the second variable it would be variable is equal to location, and the type is equal to string. Okay, the same thing I'm going to do var dot rg underscore name, and here it would be var dot location. So we have created var.rg underscore name. So what is our next step? As we do have discussed in our module part, we are only going to mention the resource block with variable, then providers, but we are not going to hard code any values which we have achieved. But to check this module, is it up to the mark or not? What we have to do, we have to create a dedicated folder inside this module. I'll say this, and then I'm going to mention virtual machine, and then in this one I'm going to mention main.tf. So this is the block we are going to have. I will copy paste this Terraform configuration. So we do have discussed to call any module, what we have to do, we have to mention a module keyword. So I'm going to mention the same thing here as module, and we are good to mention any name. I would say demo underscore virtual machine. I'm going to mention. Then the second thing, it is our source code. In the last video, we discussed when we are going to run Terraform init command, it is going to download my source code. Okay, and we need to mention the path inside the source code. So right now our source code is present inside two folders back. So we are good to mention it as like this. Then what we have to do, we have to pass the values. So the first values which we need to pass, I would say our resource group name, and here I'm good to mention it as demo underscore virtual machine underscore rg. Location I will mention here as location is equal to east US. Then what is the other value we do have? The VM configuration and the VNET configuration. So firstly I will mention here as the VNET configuration. So it would be VNET underscore config is equal to, we have to pass the values. So it is VNET underscore name. I will mention here as virtual machine underscore VNet. Then the second value which we are having, VNet address space, I will mention here as, then it is a list of strings, so I have to mention inside the list, and then 10.0.0 /16. Then my subnet name I would mention is equal to VM underscore snet. And again, the subnet address space I will mention here it as 10.0.2.0 /24, and will mention inside the comma. Okay, so this VNet configuration has been completed. What is our next configuration? The next configuration is our VM configuration. Okay, so I will mention here as VM under small module. I'll mention VM underscore config is equal to, I will just copy paste all this thing to save the time. So what would be my virtual machine name? I would mention as demo underscore virtual machine, and the virtual machine size I will mention as standard underscore F2, and the username I would mention as admin user, and for password I will just mention the this one, and the storage account I will mention here as standard underscore LRS. For publisher offer and SKU version, will copy it from the official document, which is here. See, publisher version offer and publisher offer SKU and version. If you see here what we have done till now, let me close all the file. We have created our module here, which will be our parent module, and we have passed all the required values from the main.tf. Okay, let me rename this one as test.tf folder. Okay, here I have mentioned the provider configuration, and here I have mentioned my module. Module is the required keyword and the source where our source module is present, and these are the variables which we do have mentioned inside our module. So we have passed the value. Click copy the path. I will mention the path, and right now I'm running the code inside from my VM folder, the Terraform init. So if you see initializing the modules, the next command I'm going to do Terraform plan and see if you're getting any alert or not. See, we are going to add 6 resources. Let me run quickly Terraform format to align it, and let me run Terraform apply. So it is asking for confirmation. We'll type yes. If you see here, we got an error. Unable to assume default computer name may only contain alphanumeric characters and dashes. Please adjust the name or specify the explicit computer underscore name. So what we have to do, there's some issue with the naming convention which we have followed. I'll mention it demo-vm, and let me run again. Let me type yes again and see if it is up to the mark or not. Done, we have created our virtual machine. So in this video, what we have done, we have created a module and we have called this module from the local machine only. In the next video, what we are going to do, we will push this code inside the Azure Repo, and then we will update the source block for the Azure Repo URL, and then we'll run the. Hi everyone, in the last video we discussed about the virtual machine module creation part, and once the module was created we were running the module from our local machine. What we're going to discuss, I have pushed this module inside our Azure repo. So rather than calling the module from the local machine, we are going to call the modules from our Azure repo inside the local machine. So the first step which I'm going to do, I'm going to create a file name called as main.tf. Okay. First configuration which we are good to mention, it would be regarding our provider configuration. The second thing it would be the module keyword. I would say it is my Linux virtual machine. I will mention it here. Then it would be our source is equal to here. So I have pushed the code inside the Azure DevOps in one of the branch. What I'm going to do, I'm going to click on clone. I will clone this value and I will paste it. Okay. So the next thing, as we do have discussed in the last video, we have to pass the values. So to pass the values in a real-time scenario, what we are going to have, we are going to have README file which have the proper documentation. What are the values required to run this module? But for now, I'm going to take a reference from main.tf. I will copy paste this all this value inside my local machine. If you see here, I have mentioned RG name, RG location, VM configuration, and the VNET configuration, and all the variables has been created here. Okay. So the first thing which I'm going to do, I will copy the path. I'll mention here as cd will run Terraform init. Again, I would repeat, if you see in this folder, we are only having main.tf. In main.tf, we are having our module, the source path, and these are the values which are required to run the module. See what it is doing? The first step, it is downloading our module. Download git, and where it has been downloaded, let me quickly click. See .terraform folder in modules. We are having this module name called as Linux VM downloaded, and it has all the details. So when we are going to run Terraform plan, sorry, there's one typo, Terraform plan. So what it is going to do, we do have Linux VM modules present. This is the module which we do have in our local machine. And here we do have set of variables. So when we are, so in our Terraform plan, what it has done, it has passed all the values to this module. Let me quickly run Terraform apply. Let me type yes. Our virtual machine has been created. Let me quickly check from portal. If you see here, our virtual machine has been created inside demo-rg, and it has all the details like example virtual machine, NIC, public IP, disk, and the virtual network. Okay. So in this video, what we have done, we do have the module we have pushed inside the Azure Repo, and then from our local machine we have called this Azure Repo and passed all the required values for it. Okay, we are good to push our module inside the other remote repository. What we have to do, we have to only update this path according to our URL. Okay, so thanks a lot for watching the video. In the next video we are going to discuss about the state management. Thank you. Hi everyone. In this video, we are going to discuss about the remote state management. Basics of backends. Backends determine where Terraform stores its state. By default, Terraform implicitly uses a backend called local to store a state as a local file on test. So what is the exactly meaning of it? So till now, our state file is creating where in our local machine. So what is the exact meaning of local machine? The place from where we are running our code. Okay. In the last example also, what we have done, we have called a module on this source path and we have passed the variable. So the state file which was created, it is present inside our local machine. Okay. Challenges with local backend. In modern infrastructure as code practices, especially when using Terraform, collaboration amongst team is key. So what is the exact meaning of it? In real-time scenario, whenever we are going to work on Terraform project, we are going to have a dedicated team for it. Okay. It should not be done by only one user. Okay. When working with Terraform, a state file holds a critical information about the infrastructure, including resources, configurations, and dependency. What is the exact meaning of it? In the initial lecture, what we have discussed, we do have concept called desired state and the current state. So the desired state, whatever we do have mentioned in our Terraform configuration, and the current state, whatever we have deployed. To balance between the desired state and the current state, what we need an state file. Okay. So for any configuration, whenever we are going to run Terraform plan or Terraform apply, each and every time the state file configuration is checked. Managing the state file properly becomes essential for teams that collaborate on same infrastructure project. So what is the exact meaning of it? Let's take example. I have built a Terraform code to create resources like AKS, ACR, API. Okay, I have dedicated module for all these resources. I'm just calling the module from another place and just passing all the values. Okay, so if I'm going to store the state file inside my local machine, tomorrow if any other user want to do any changes in AKS, ACR or APIM values, will he able to do it? No, because we have stored our state file inside the local machine. So what we need to have? We need to have a centralized place where we are good to store our state file. So anyone else from our team good to connect from his or her local machine. So what would be the ideal architecture? Following describes one of the recommended architectures. The Terraform code is stored in a Git repository, providing advantages such as collaboration, versioning, change management, and automation. What we have discussed in the last slide, we are planning to create AKS, ACR, APIM. Okay, so for this one, what we have done, we have created a dedicated module, and this module code will be stored in a dedicated repo, I would say. And we do have data engineering project, and in the data engineering project what we are doing, we are just calling all these modules and we are passing the values for it. Okay, so the best practice is to store all our code. It would be a central git repo, one repo, it would be dedicated for all our modules, and the second module it would be for all our projects. We are not good to store our state file in a local machine from the place where we are calling all this module, because today I'm working on this project, tomorrow it would be like a different person from my team who wants to do any configuration changes in all this value. So what we have to do, we need to have a central backend where we are going to store our state file. Okay, so the whole architecture it would be like this. We do have our central git repo, the place where we are going to store all our Terraform configuration file. Parallelly, the Terraform state file, it would be stored inside our central backend. So the backend supported in Terraform. Terraform supports multiple backends that allows remote services related operation. Some of the popular backends include Amazon S3, Azure Blob Storage, Google Cloud Storage, HashiCorp Console, HashiCorp Terraform Cloud Enterprise. So what is the exact meaning of it? It means in the last slide, what we have mentioned, the central backend, we do have n vendor where we are good to store our state file. But in this video, we are going to store our state file inside the Azure Blob Storage. So exactly where we need to mention the configuration related to backend. If you see here, what I have mentioned a backend keyword, and inside the backend keyword, I have mentioned Azure RM, and these are the values which I have to update. Resource group name of my storage account name, what would be my container name, and what would be the file name of Terraform. In key, we are good to mention the any state file name, but we have to mention extension .terraform.tf state. So in the next video, I'm going to do a demo on it. Hi everyone, in this video, we are going to do a demo on remote state management. So what we have done till now, we have called this module name called as Linux VM, and our source code is present inside our Azure repository, and these are the values which we have passed. So whenever we are running Terraform init plan apply, our state file is getting stored where in our local machine. As we do have discussed in the last video, the best practices is to store the state file inside the remote state management rather than in local backend. Okay, why we need to store our state file in remote state management? The first thing, it would be like, in terms of security, we should store our file in remote state management where we are good to have different kind of replication, versionings, and the other configuration. The second thing which I would say which is required for the remote state management in terms of team collaboration. Right now, I would say we are having a Terraform team, and in this team we are having member 1 and member 2. So if member 1 wants to do any changes from his local machine, then the state file will be present inside the local machine only. And parallelly, if member 2 wants to do any changes in this code, the state file will be present inside the local machine only. So the best practices is to have a dedicated remote state management where we are good to store our state file configuration. So what are the value we need to update for our Terraform state management configuration? If you see in official document, what we have to mention backend keyword, then Azure RM, then the resource group name, the storage account name, and the container name, and finally the key. As we do have discussed in the last video, if you're we have to mention the extension called .terraform.tf state for the key. Let me copy it and paste it inside our Terraform configuration. I would mention the storage account name as Terraform storage account and will mention some random value to make it unique. The TF state is fine, then the key is fine. Let me quickly create a storage account with this name. Uh, the resource group name it would be storage account hyphen resource group, and this storage account name which I'm going to mention TF storage account, and the container name we are going to update once our storage account it would be created. I'm going to mention it as LRS review and create. Let me click on create. So our resource group and the storage account has been created. What is the next step we need to do? We need to create a container with a name called TF state. I'm going to click on containers, create. the TF state created. So uh, if you see here, what we initiated a command called Terraform init. The first thing which is happening, initializing the backend and successfully configured the backend as your RM. Terraform will automatically use this backend unless the backend configuration changes. So what does it means? Instead of local backend, which means to store our file in the local machine, it is going to use what? Azure RM provider. In the Azure RM provider, to be very precise, inside this storage account, the container name tf state, this state file will be created. Huh? Let me run terraform apply to save the time. If you see here, our resources has been created and currently we do not have our terraform state file. So where is our terraform.tf state file? The terraform state file is inside this tf state container. Let me quickly check it. See, we are having our Terraform state file stored inside our TF state container. So if I'm going to run again, Terraform apply -auto -approve, let's see what is going to happen. See, it is showing like, hey, no resource is going to be added, changed or destroyed. So each and every time it is going to connect to the remote backend. So what we have to, so what we have discussed till now, this is from my local machine. Okay, I do have one repo where I have stored all my Terraform configuration in terms of my module. The second file is our remote backend where I have stored all my state file. Okay. And what I'm going to do after my changes, again, I'm going to push my Terraform configuration inside a dedicated repo. I would say it would be dedicated for the project configuration. For the project configurations, and our state file, it would be this one. Tomorrow if anyone else want to do any changes in this Terraform configuration, what they're going to do, they're going to clone this project inside their local machine and they're going to do the changes, and parallelly our state file will be updated. So this is the basic benefit of using remote state store.